Hey, good evening, ladies and gentlemen, and welcome to another video. In today's video, we're going to be learning about the types of rocks, and we're going to do some practice questions together and give a nice summary to everything that we are going to learn today. So let's dive right in. As you may already learned in your elementary school or from your middle school, there are three types of rocks. You have the igneous rock, you have the sedimentary rock, and finally the metamorphic rock. So we're going to dive deeper into what each of these rocks are and how one differs from one another in the way they form. All right, so let's dive right in. So igneous rock. Igneous rocks are formed from the cooling and solidification of magma or lava. Now, magma and lava are two words that are often used interchangeably, but there's a slight difference. Magma is when the molten rock does not make it to the Earth's surface. Lava, on the other hand, is when the molten rock makes it to the Earth's surface. All right, so there's a slight difference between the two. But either way, whenever this molten rocks cools down, it forms igneous rock. That is it. Cooling and solidification of molten rock, magma or lava. Now, like I just explained, the molten rock can make its way to the Earth's surface, then it will cool and solidify on the Earth's surface. You call that extrusive igneous rock. While the magma that did not make it to the Earth's surface, that is trapped deep inside the Earth and cools and solidifies deep inside the Earth, you call those intrusive igneous rock. Extrusive as in external, exterior, exposed. Yeah, extrusive igneous rock. While intrusive means inside, trapped inside, intrusive, included. All right, so that's the difference between extrusive igneous rock and intrusive igneous rock. One is produced by lava that made it to the Earth's surface, the other is produced by magma that did not make it to the Earth's surface. All right, these are common examples of igneous rock, both extrusive and intrusive. Now, extrusive igneous rock include pumice, obsidian, and basalt, and intrusive igneous rock include granite and gabbro. All right, so we're going to be summarizing everything we've learning along the way using this flow chart. So first, we established that rocks are of three different kinds. You have the igneous, sedimentary, and metamorphic. And we just learned that igneous rock is formed by the cooling and solidification of magma or lava. And this can be in two kinds. You can have intrusive igneous rock, which include gabbro and granite, or you can have extrusive igneous rock, the one that made it to the Earth's surface by cooling and solidification of lava, and that can include basalt, rhyolite, or andesite. Cool. So let's dive in. If I'm moving too fast, feel free to play the content back and ensure you grab the content as we ride along. Next, we're going to look at sedimentary rocks. Sedimentary rocks are rocks that are made from sediment, which are broken pieces of rocks. Now, these kind of sedimentary rock are referred to as clastic sediment or land-derived sediment. This simply means that other rocks have been broken into pieces and they are moved and deposited into a marine environment, into deep waters, and that sediment begins to accumulate over time, over the years and over the millennium and over the decades and over the centuries, spanning into periods and eras and eons. These sediments begins to accumulate and accumulate at the bottom of the ocean. All right, so this kind of sediments that are produced this way are referred to as clastic sedimentary rock because their sediments were derived from the land or were derived from pieces or fragments of other rocks. So as that process continues, more often than not, some of the sediments bury some living things. So you see that this sedimentary rock would often contain what you call fossils because they bury either plants or they bury dead organisms or animal shells, and they preserve them as the accumulation process continues to occur. And also, these land-derived sedimentary rocks are formed in layers All right, you see the deposit occurring from one layer to another layer as the different eras and eons are passing by. Again, this sedimentary rock are referred to as clastic sedimentary rock or land-derived sedimentary rock. So this kind of rocks, like I said earlier on, would often contain fossils of different organisms. This could be animals, or this could be plants as well. And we also established that they form in layers, 9 layers as well. So these are clastic sedimentary rock or land-derived sedimentary rock. Common examples of this rock include conglomerates, breccia, and sandstone. Often their characteristics is that they are formed by different sediments having different size, different grain size, all cemented and compacted together. The breccia, the same thing, and then you have sandstone being formed in nice neat layers as well. Now, there are other kinds of sedimentary rock that are not produced this way. These sedimentary rock are produced by chemical processes. So these chemical processes involve the growth of crystals. Predominantly, the chemical processes are either evaporation or precipitation, which means as water is being evaporated from a marine environment, something is left behind. Precipitation, or these chemical compounds that are inside or dissolved in the water, are left behind as the water evaporates away. So this leads to the growth of crystals and the development of this sedimentary rock. Again, the two main processes here is evaporation and precipitation. Those are the two main processes that produces chemically formed sedimentary rock. Common examples include gypsum and rock salt. All right, other kinds of sedimentary rocks are organic sedimentary rock or biologically formed sedimentary rock. As the word implies, organic, which means it came from an organism. Or when you hear the word biological, bio, which means life, something that was once alive. So organic sedimentary rock are rocks that are formed from the remains of plants and animals. Common examples include chalk, limestone, coal, and limestone that has a lot of shells in it if you look at that picture carefully. So these are the common types of sedimentary rocks that are formed from the remain of dead plants or animals. So let's go back to this lovely chart here and see how we can separate all of that information. First, we said sedimentary rocks are rocks that are formed from the sediments of other rocks, pieces of other rocks, and those kind of sedimentary rocks are referred to as clastic or land-derived sedimentary rock. Common examples include conglomerate, breccia, sandstone, siltstone, mudstone, and shale from the pieces of other rocks, basically, and they contain fossils and they are formed in layers. The other type is the chemically formed sedimentary rock from the development of crystals through the process of evaporation or precipitation. Common examples include evaporates, dolostone, rock salt, gypsum. And then lastly, you have the biologic or organically formed sedimentary rock, and these include coal and limestone. Now we move over to the last category of rocks, metamorphic rock. Now, metamorphic rock are rocks that come from other parent rock, which means they are pre-existing rock and are subjected to enormous pressure and enormous heat. Okay, we're going to dive a little deeper where this heat is coming from, but basically the heat is coming from deep inside the earth, from the lava flow that we talked about earlier on. And when that lava or when that heat comes in contact with other rocks that are already pre-existing, they change them, they recrystallize them. It's a way of saying, oh, I have red meat and then I'm going to cook it or barbecue the red meat and now I have a steak. Typically it's the same thing. One is cooked, the other is just raw. So the parent rock or the original rock is the red meat. Then once it has been subjected to heat and pressure or cooked or recrystallized, then you have another product called steak. That's just the difference. So that's what metamorphic rock is, just a metamorphosed, a changed rock from what it used to be as a result of high heat and intense pressure. Okay, so like I explained earlier on, this heat could be coming from deep inside the earth, or it could be as a result of accumulation of pressure from on top of the earth's surface, or when tectonic plates are moving. That's something we're going to discuss in another unit later on. But the main idea here is heat and pressure are responsible for metamorphism, or the production of metamorphic rock. So as a result of that heat and pressure, some metamorphic rock would form mineral alignment, which means the minerals that the rock contains would form lines. Like you can see here in phyllite, you see those little lines there. You can see in gneiss as well, you see those bands, those lovely minerals, or the white mineral separating from the black minerals. So whenever you see rocks or the minerals separating in that way, it's called foliation or mineral alignment, which means the minerals are making or separating themselves into different lines or into different bands. There are some other metamorphic rock that do not exhibit that, mainly because they contain only one mineral. A little more information on that in our subsequent class. But basically what I want you to take away from here is that heat and pressure is responsible for metamorphism, and some metamorphic rock have what you call foliation or mineral alignment. All right, let's wrap it up. Metamorphic rock can be foliated, which means aligned or minerals forming lines, and common example include schist and gneiss. And then you have those that are not foliated, and common example include quartzite and marble, mainly because they contain only one mineral. And that ends our recap of this lesson. We're just going to go through some recent questions, and then we wrap it up there as usual. All right, let's look at question number 1 here. Question number 1 says, which process is necessary for the formation of igneous rock? The formation of igneous rock. If there's anything we know about igneous rock, is that igneous rock forms from the cooling and solidification of magma. So our best answer here would be solidification, right there. Option number C. Question number 2. Most rocks that form from fragmentar rock particles are classified as, which means this kind of rocks are formed from fragments or particles of other pre-existing rock. And the only kind of rock that we talked about that is formed in that process is clastic sedimentary rock. We established that igneous rock formed from the cooling and solidification of magma, so option A is out. Option B is also out as well. Chemically formed sedimentary rock involve evaporation and precipitation and the growth of crystals, so option D is also out of the way. Only clastic sedimentary rocks are formed from the fragments of other pre-existing rock, land-derived sediments. Question number 3. The diagram below shows 4 rock samples, and the question is, which sample best show the physical properties normally associated with regional metamorphism? As we discussed earlier on, when rocks are being metamorphosed or undergoing heat and pressure, the minerals begin to form lines as a result of the heat or as a result of the pressure. So if you look at this rock sample A, B, C, and D, which of them exhibits that? Which of them shows minerals being formed in line or being formed in bands? If your guess is as good as mine, is option A, definitely in there. All right, option B does not show any mineral alignment or any sign of metamorphism. It's typically a sedimentary rock because I see pebbles and other grains of particles of other rocks in there. Option C is definitely also a sedimentary rock. I can see it has some fossils. And sample D does look like an igneous rock. Definitely not metamorphic because it does not show any mineral alignment or banding. Question number 4, same thinking process would apply here. Diagram A and B represent magnified views of the arrangement of mineral crystals in a rock before and after being subjected to geologic processes. So you have diagram A here and diagram B here. The question is, which geologic process are most likely responsible for the banding and the alignment of the minerals represented in diagram B? So If your guess is as good as mine, this definitely has to do with metamorphism, which has to do with heat and pressure. So our answer here would be melting and solidification, no. Compaction and cementation, no. Heating and increasing pressure does look like it. That is metamorphism, a result of heat and pressure. So our correct answer there is B. Question number 5. The wavy bands of light and dark minerals visible in gneiss bedrock probably formed from the, so bands and wavy bands, that sounds like mineral alignment. The minerals, the dark minerals being separated from the light minerals, that definitely is as a result of metamorphism resulting in mineral alignment. So my option should be something that would tally or connote metamorphism, and our correct option there should be heat and pressure during metamorphism. Option D right there. Let's look at the last question. Question number 6. A student classified the rock below as sedimentary. Which observation about the rock best supports this classification? So we see the rock there, it has different grains, different fragments, different pieces of pre-existing rock that were squashed and cemented together. So that does look like sedimentary rock. So what observation do we see that makes that student to classify this as a sedimentary rock? A, the rock is composed of several minerals. Many rocks are composed of several minerals. So that is definitely not our option there. Option B, the rock has a vesicular texture. Vesicular texture simply means gas pocket, like gas bubbles everywhere. I don't see gas bubble in that rock sample. Option C, the rock contains fragments of other rocks. Definitely, that does sound and look like our correct option in there. And option D, the rock shows distorted and stretched pebbles. No, those pebbles are not distorted nor stretched. All right, that's the correct answer there, and that is a wrap for today's lesson. Exit ticket coming shortly, and I'll see you all in the next video. Bye for now.